next session is double number lines in proportional reasoning. Our speaker is Keith Nabb. Keith is an associate professor of mathematics at Piedmont Virginia Community College in Charlottesville, Virginia. His interests include active learning, math knowledge for teaching, and equitable classrooms. If you have any questions during the session, please feel free to enter those into the chat section at the bottom of the Zoom room screen, and we will address them at the end of the talk. On that note, I will hand it over to you, Keith.
All right, thank you. So hello, Wisconsin people. So I'm in Virginia now. I definitely miss all of you. The weather is much warmer here. So I'm totally cool with being interrupted at any point. I like the fact that this is not a webinar format, so feel free at any time just to interrupt. My students do it all the time. All right, so can everyone see everything okay?
Looks good.
Okay, looks good. Awesome. Okay. So I shared this with Amatic, I think it was a year and a half ago or maybe 2 years ago. So I have similar data here, but this is one of those topics dear to my heart, right? Teaching about proportional reasoning, because this is one of those topics that really sits right there at the gateway to algebra. So I find that students really should have a strong understanding of this area. So I'm going to talk a little bit about that. And I think this session will be pretty short. I think I only have a half an hour, so I might just chat a little bit. And then if you have some questions about this at the end, we can definitely address that. All right, so this is the problem here. I want everyone to take a minute maybe just to read it. This is a great problem in which I usually start the proportional unit with a problem like this. So take a second to look at that. And when I think of this problem, usually because I'm teaching pre-service teachers, I just think of elementary school children drinking soda, right? So it makes for an exciting context. So I love this problem. I don't know what it is about this problem, but it's a great problem to introduce covariation, right? So that kind of reasoning. And another reason I really like it is it's just hard enough that usually my pre-service teachers can't do this in their head, right? So they actually have to write something down to figure out how do I come up with a solution to this problem. So that's one of the reasons I really like it. But maybe if you want to unmute yourself, if you give this to a group of math for elementary school teachers, maybe you could tell me, what do you think they're going to do with this problem if you ask them to solve it with no instruction?
Yeah, this is John. I would say that the students might try to set up an equation.
Exactly. So this is the common route. Anyone have something else? Because I think John hit on the one where I saw this from about 80% of my students, right? To write down some kind of equation that connects the grams and the ounces, right? And then they solve the problem from there. So when I did this, right, without any teaching at all, this is basically what I got from almost all of them, right? So they had this desire to set up something with ounces on the top and grams on the bottom, and then we have that unknown in there. And so they did this in pairs. They were able to successfully do it. But the one thing that sort of made me sad, right, because these are going to be math teachers here, is they didn't really quite understand the answer, right? They didn't understand why the answer was, I guess here it ends up being 7.5, right? So 7.5 ounces. And many of them, they couldn't explain why that was the answer. So they couldn't really comprehend that the fraction 12 divided by 40 is the same as 7.5 over 25, right? So they were grappling with understanding the answer. And of course, part of this is I don't use the H word very often, right? And that word is hate, but I really do hate cross multiplication. And this is something I actually have on a mug. It says, I hate cross multiplication. So my students basically did that in this problem. They were able to get an answer and they were happy with it. So my goal here was, is it possible I can introduce another tool, right? Something a bit more conceptual where maybe it will bring some meaning to the problem. So I introduced for them a double number line. And so this is the solution that I presented for them. I said, I want to show you a new tool. And I did check with the class and there wasn't a single person in the class who had heard of a double number line. So a double number line is basically an open number line, right? So it's completely unadorned and you have to do all the decorating. So I did this problem for them, and I think you can detect by looking at it, the sequence in which how this was solved. Let me see if I can use my pointer here. So one number line I labeled as ounces, the other one is grams. And I think you could tell I started right here where the star is. And what I did was a bisection, right? I took the 12 and 40 and I cut everything in half and got 6 and 20. And then I did 2 more bisections, right? Because what I was trying to aim for here was 25 grams on the lower number line. So right in between here, you can see the 9 and the 30. And then I did 1 more bisection and there it is, right? So the answer there I circled 7.5 on the top number line, 25 grams on the bottom one. So I don't wow my students very often, but they were wowed when they saw this because remember I had just asked them to solve the problem, right? And so they could see the 7.5 ounces and their comments were things like, it took me so much work to get 7.5, right? But they liked the fact that they could see relationships, right, in the double number line. So they could see the connection between the ounces and then also the grams of sugar. So guess what? So I showed them this, just this one example. And then there was a student in the room that looked up and she said, that's not how I did it, right? So what I did is I grabbed her solution. Remember, this is introduction to the double number line, so they had never seen it. And so we put her solution up on the board or on the doc cam, and this was hers. So maybe someone can chime in here. What did she do? Because I think I call her Michaela. What did Michaela do on this problem?
Same thing, repeatedly halved.
Yeah, thanks for that, Stephanie. But what did she do that's a little different? See, this was mine, right? So look at my solution. Pretty cool, I like it. But I really like Michaela's too. What's going on here?
Looks like she broke it down to a smaller unit that she could use to build back to 25.
Yeah, right. So the thing that struck me, right, when I saw her solution is, and she even wrote it here in pink, right? She used like this additive reasoning in solving this problem. So she did something a little different. She started out with 12 and 40, which is obviously the starting point, but she continued to have, as Stephanie mentioned, and then it caught her attention here. I've got a 5 and I have a 20. So if I add those two, I have my 25 grams. So then I can just take the 1.5 and the 6 and I have my answer to the problem, right? The 7.5 ounces. So here I was trying to sell to my students that double number lines are, allow for flexible thinking, and they were kind of doing this for me, right? Because I had a student who was able to generate a slightly different solution for her classmates. Okay, so after this happened, I thought to myself, I have to gather some data, right? I need to know the answers to these questions. So this was a really small thing where just for a subunit, I wanted to gather some data. And these were my 2 questions. I wanted to know, are these effective, or do the pre-service teachers actually find them to be helpful tools? And do they allow for different solution paths, right? So different ways of thinking about the problem. And this is the problem where I'll show you most of the data here. So this is about making pizzas. I can't remember the source of this problem. I think it's an NCTM book because the names are hard. I think it's Kilo, right? So Kilo makes 3 pizzas in 5 minutes, and Casey makes 4 pizzas in 9 minutes. And the question here is, if they make pizzas at that rate, obviously we ignore fatigue. Who would win a pizza making competition? So the big thing here is I wanted them to justify their work. And this was actually an assessment item. So this was on a test at the end of the unit after I already taught the unit on proportion and rate, right? So all those topics with fractions. So when I looked at the data here, the solutions pretty much fell into 4 categories, and I'm going to share those with you because these are really interesting. So these are examples of the student work. So the first category is unit rate. So if any of you teach math for teachers, you're going to say, holy smokes, the student work is kind of almost guiding the curriculum for you. So if you look at this problem, you can see the starting point, right? 3 pizzas, 5 minutes, 4 pizzas, 9 minutes, right? So this student started off that way, and she immediately went to unit rate. I can safely almost say she for all of these students, because whenever I teach this class, there's 1 guy, right, and 32 girls in the room. That's typical. So what she did anyway is she unitized on time, right? So she said in 1 minute, Keela makes 3/5 of a pizza, and in 1 minute, Casey makes 4/9 of the pizza. So she reasoned from here, Keela makes more or a bigger part of a pizza, so she would win the contest. So great use of the number line. And here, naturally, we expect this to happen the other way, right? So this is another unit rate, except we're unitizing on the pizza. So if you look at the top solution, 1 pizza, right? You can see the time it would take Keela to do it, and likewise for Casey. Now, why do I love the double number line? It's because the student still has to think, right? So if you look at the top solution, right, students tend to think the bigger number is going to give me the answer. But for this one, for example, it's the smaller number that gives you the answer, right? So we're unitizing on the pizza, so we're looking for a smaller time. And you can see the explanation off to the right justifies that, right? So it's a great tool because instead of cross multiplying, they actually have to think about the meaning of the answer. So those were great. The second class I found is like least common multiple. So being in a group here with a bunch of mathematicians, you'll recognize the solution, right? It's a great one. You can see again, the starting point 3, 5, and 4, 9, they're all the way to the left. But what this student did is they just scaled each number line to 45 minutes, right? So you can see times 9 on the top and then times 5 on the bottom. And you can see that Keela makes more pizzas, right? 27 instead of Casey's 20. So the answer is just right there, right? They can see it. So in a similar way, exactly the same here, right? So you can scale on the number of pizzas, and you can see that Casey takes longer to make the same number of pizzas. And so again, what I love here is just the flexibility, and the students are using whatever they see in the double number line to generate a solution. I like this one because what you can tell is this student, actually when I spoke to this student too, she unitized, right? Like the earlier solutions, you can see the 1 pizza on both of these, but then she admittedly got flustered. She's like, I don't like 9/4 and 5/3. So I changed gears, right? So she took the 1 and then just multiplied by 12 and did that in both categories. So you can almost see a blended solution on the screen, right? So she just did whatever made sense to her. All right, cool. Solution 3, I think this one's my favorite because this one here really shows just the power of double number lines. And you can tell this is not anything that I did with my students. This is something that it's inherent in the tool. So you can see the starting point, the 3 and the 5, and this student halved and got some pretty messy numbers here. And also you can see the 4 and the 9, and she halved again. So the interesting thing here is she seized on the 2 for Casey, and then seized on the 3 for Keela. And she said, why don't I just go to 6 pizzas, right? So there's no need to go to 12 pizzas to make a comparison. I can just go to 6. So this is almost a combination of, it's almost like least common multiple, but she was using the original information for Keela and then the adjusted information on Casey. So this convinced me that the double number line is just awesome, right? Because when I first saw this, you can imagine when I'm grading this, I'm like, what is this? This makes a lot of sense, right? To solve the problem this way. And I think I have another one to show you. This blew my mind, right? So this is not something I taught my students, right? So this is something that the student pretty much invented. She made a triple number line on her test, right? So why not, right? Covariation. This is like trivariation. So you can see Keela, Casey, and time. This is incredible. And she lined these up, right? 3 to 5 are lined up and 4 to 9 are lined up for Casey. But then you can see that multiplicative scaling, right? So she went right to 45 minutes for both of them and then adjusted their pizzas. So this one here, I actually showed to the class because I had never seen it before, and they clapped for her because this is incredible, right? To actually to invent something slightly new, right? But just based on the information that we already learned. So great solution. All right. So I had to make sure that it wasn't just me that was loving this, right? Because these are teachers. They're going to go into our they're going to teach our children, right? And I needed to know how did they feel about double number lines, and I gave them the outlet to love them or to hate them, right? And so I did ask them just a quick exit slip question, and I did want to show you just some of the data. And this is pretty representative of what all of them said. I might have had 1 or 2 that said, it's okay. But this was the majority of the responses that I received. So you can kind of skim them if you want. And these are, sometimes we get this language like weak students. I don't like to talk about weak students, but, we see that language still from time to time. I do like this question. Why isn't there more stuff like this in other areas? So for a lot of these teachers, they're reflecting on the fact that they're going to have to take this into the classroom. This one here in the light blue, I love how you can use whatever you see first, and we see that in the data, right? That the solutions are very, very different. And this one here, I love that they can go about it in different ways. This student said kaboom a lot, so I actually know who this student is. I can see her in my mind, but I love her comment. I find it oddly satisfying that no one solution is the best, right? They're just all kind of there, and they're very personalized, right? So the students are leaving their mark on the solution. You can tell it's very personal. I think my favorite one is the one I skipped over. It's the one in green, right? So if you look at that one, my favorite part is that you can see more than one answer to the problem within one solution. And what I think the student meant here is not more than one answer necessarily, but you can see relationships, right? So if you think of the COLA problem, you set up that proportion, you cross multiply, you get the answer, right? You get the 7.5 ounces, but you see no relationships at all. But if you look at the double number line, every single connection where the numbers line up, you basically see another connection in the problem. And so that was a moment for this teacher, right? She could see like, this is a tool that facilitates learning, right? Actually helps students. All right, so my highlighting didn't show up. That's all right. Okay, so that is awesome. I love these things. I do want to I'll show you one more thing though that surprised me. There's another problem here, and this one is about discounting. So take a second if you want to look at it. This is a pretty hard problem. So if you haven't been to this website, it's still incredible. There's so many very rich tasks, because I know John Oates was talking about rich tasks, right, for IBL. You need to give them hard things, right, if you want them to do wonderful things. So anyway, this was several weeks after I was already done with proportional reasoning, right? We were done with that unit. So we were well on our way to something different. We were talking about decimals and percents. And so this was one of our whiteboard tasks of the day. And we were using things like decimal grids and even like tape diagrams, right? So some different tools to solve these problems. So when I gave them this problem though, I was stunned because some students were still using the double number line thinking, right, from several weeks ago. So we had tabled this. And so I wanted to show you this. This one here did generate a round of applause in the class, right? So this problem is basically saying, for what full price is 15% off the same as $18 off, right? So it's a kind of a difficult problem. And this is all the students did, right? So this was a group of 2 in the back. And so I think you could tell what they did, right? They took the 15% and said, I'm just going to break that into 10 and 5. So that means one of them has to be double the other. So that was pretty easy to figure out for $18, the 12 and the 6. And then you'll notice the solution is instant, right? So if you know 10% of the price, it's so easy to get 100% of the price, or even 5% of the price, very easy to get to 100%. So this is like using a ratio table, but when they explained it, they were basically talking about these special locations. So in their mind, they were saying, I was actually thinking of dollars on one number line and percent on the other. That's exactly how I solved it. So they were still, that reasoning stayed with them, even in a different unit. What else? And this one was also in the room. It was explicit, right? So if the other one didn't suggest a double number line, this one, they actually used it. So I'll just mark the starting point. You can see it right here, 18 bucks, 15%. And they just dropped back to 5%, and they just decorated this beautifully. And then they jumped to 20, and then they jumped to 100, and you can see the price. Great tool, right? So this is still something that if I give this to, for example, like a QR class, they're going to try to do guessing and checking. If they've had algebra, they might set it up by modeling, right, with some kind of equation. But this format here is just so incredibly clean, and they see the connections between the dollars and the percent. So it had staying power. Anyway, I think I'm done. I just wanted to show you some of those examples. That's my contact info if you want to, chat about double number lines. But I thought, if we have questions or things, that would be awesome. I'm going to stop sharing here because we have a few minutes. But I'm curious, like what you might think about them. What are your thoughts, or do you have questions for me?
Feel free to unmute yourself, ask a question, type it in the chat. I'm happy to monitor those for you, Keith.
I threw my hand up there, Keith.
Sure.
I only caught the tail end because I was dealing with some technical difficulties in the other session. So just FYI, we're starting the business meeting at 11:15. My question was more of a technical issue. Since everything's been recorded, can we go back and watch these, Catherine? Like Keith, I caught the tail end and now I want to see the beginning. So
yes, we'll post the recordings. Since it's just continuous, we have to chop them up, and we'll get them all prepared and have them on the website next week.
Okay, awesome. Because I'm sure other people probably stepped in and out too, because I know I've stepped in and out to take care of my son because my wife was working today unexpectedly. So life happens. Thank you, Keith.
Yes. So any overall questions? I mean, I don't know. I'm sure everyone in the room has had to teach, this concept at one point or another, but.
Hi, Keith. I have one question.
Yeah, sure.
So what other topics have you used double number lines except ratio and proportion and rates other than that?
Well, this is the thing. It's a covariational tool, right? So it's designed specifically for ratio, proportion, and rate. So those areas. So that's where I introduce it. And I guess the thing that surprised me is when they continued to use it. So they felt so comfortable with the tool. So we're sitting there in the decimal and percent unit talking about different manipulatives, and they're still using the other tool. So that was an epiphany for me, like it stuck with them. So I'm guessing there are other areas in which it can be easily applied. Anything where you have covariation, because you basically have the 2 number lines, or you saw the triple number line as well. So
yeah, I love this concept that you can visualize it, and once you see it, it's stuck in your mind and you can carry this on. And I'm pretty sure students can retain this much longer than just cross multiplying and that. So I really like the idea. Thank you.
yes, you're welcome.
Any other questions? I see a lot of comments in the chat for you, Keith.
Oh, okay. Yeah, I haven't been looking.
Yeah, just a lot of comments in there for you to take a look at. But any other questions before we wrap this session up? Perfect.